In this video, I want to explain why analytics is often slow, what's usually causing it, because performance is one of the most common frustrations with analytics. Dashboards that take too long to open, filters that lag, reports that time out, or systems that just feel fast one day and then slow and painful the next. A useful way to think about performance is analytics is slow when the system's working harder than it needs to. And that extra work usually happens in one of four places, and if you can spot which one it is, you can usually move the conversation in the right direction quickly. Sometimes analytics is slow because it's pulling data from places that weren't designed for analytics. In some setups, analytics tools are still querying operational systems directly, so that's things like your ERP, CRM, data lake. Within analytics systems, you might hear terms like live connections or direct queries, but operational systems aren't really built for this. They're built to process transactions, not answer analytical questions. So when analytics relies on them too heavily, then performance suffers both in the ERP and the source system, but also downstream of that. Even when the data comes from a warehouse, performance can be slow if more data is being queried than is actually needed. If a dashboard only needs recent summaries, but it's pulling years of individual transactions, then the system has to scan and process far more data than necessary. The level of detail matters here too. Querying every transaction instead of aggregated totals is going to dramatically increase the workload. The more rows and columns that are involved, the harder the system will have to work. You can think of it as asking somebody to read an entire book when all they really need to do is read one paragraph. Another common cause of poor performance is when complex things are happening too late in the process. Sometimes calculations, reshaping, and joins are performed when someone opens a dashboard instead of being prepared earlier in the ETL. You might hear phrases like transformations at query time or complex joins, but what this means in practice is that the system's rebuilding answers every time someone looks at the data. And when too much logic runs on demand, performance becomes slower and less predictable. The fix for this is usually to move that upstream so the dashboards are reading from prepared data rather than calculating things at runtime. An analogy here that you can think of is it's a bit like a chef preparing their ingredients ahead of the orders rather than every time an order comes in, they go and prepare all of the individual ingredients and then cook them afterwards. Performance isn't just about how much data exists, it's about how the data is organized and how quickly the system can find what it needs to find. If the data model is overly complex or unclear, the system has to work harder to answer simple questions. You might hear terms like dimensions, fact tables, star schemas, but these are just ways of organizing data so queries can run efficiently against the data warehouse. Other terms that you might hear around this are indexing and clustering. Basically, these help systems find data quickly. These are just database terms, but you can think of them as organization methods that stop the system from searching everywhere to find what it needs. And it's pretty similar to how a library works. Books are clustered by category, so you have fiction, non-fiction, etc. So you don't have to then search the entire building to find what you're looking for. And within each of those sections, books are indexed often by author or by title, so you can find a specific book very quickly. And databases use similar ideas, so queries don't have to scan every single record to find the answer it's looking for. And sometimes the issue is just simply capacity. Even a well-designed system needs enough compute power to handle the workload at the speed that people expect. But the key takeaway here is still a well-organized warehouse is going to be much faster to navigate than a messy storage room. And so you want to be using the ETL and building out a data warehouse, not connecting directly to the source, but also having good practices in between. Even when the data layer is solid, performance can suffer because of how dashboards and users are interacting with the system. Each visual on the dashboard often triggers its own query, and a dashboard with lots of visuals can send dozens of data requests all at once. When you combine that with filters and cross-filtering, it also increases query load pretty significantly, especially when you're using large data sets, broad date ranges, and so on. Also, some tools generate inefficient queries, depending on how visuals are built, which adds more unnecessary workload. But also user behavior plays a role here too. If you're selecting all time by default, loading everything at once, or exploring really broadly without really narrowing down a question that you're trying to answer, all of this is going to increase processing demand. Finally, many users run heavy queries at the same time, so resources get stretched. The same dashboard can feel fast with one user, but not so fast with 50 or 100. I'm not saying that you shouldn't have many concurrent users because a well-designed system should be able to handle that, but if you're already struggling with performance, then this is just going to amplify those issues you have. A key reason performance problems tend to stick around is that they need an end-to-end view. For instance, you can optimize a dashboard and still have slow performance if the model is heavy, or you can optimize the warehouse and still have slow results if the dashboards are asking for too much data all at once. Performance tends to improve fastest when somebody's looking across the entire chain, not just one layer at a time. And the best way to make progress is to bring it back to those 4 areas. Are we pulling too much data? Doing work too late in the process? Modeling and storing data inefficiently? Or are we asking the front end to do too much all at once? Performance links directly back to architecture I discussed in the previous video. Good architecture doesn't just give you correct numbers, it also gives you fast, predictable access to those numbers. So when somebody says analytics is slow, what they're really saying is something in the pipeline is working harder than it needs to. One thing to keep in mind is high volume doesn't have to mean slow performance. It's possible to have billions of records and still get sub-second dashboard performance, but you can only get that when the foundations are solid, and as the data gets bigger and bigger, you just have less room for poor architecture, unclear definitions, and bad user habits. So that's going to do it for this video. I'll see you in the next one.